Less than 1 year ago, the entire world encountered an extraordinary and devastating climatic catastrophe, the true nature of which had remained shrouded in mystery for many years. This disaster was so profound that it radically altered the very fabric of the planet's environment, leaving humanity perplexed and searching for answers. During this catastrophic event, the sun, typically a symbol of life and warmth, suddenly dimmed and lost its usual brightness, casting a gloomy shadow over the Earth. From the skies, an unusual blood-red rain fell, soaking the land and adding a surreal, almost apocalyptic hue to the scene. At the same time, the clouds became thick and heavy, filled with fine dust particles, enveloping the entire surface of the planet in a hazy, bleak veil. The effects of this calamity persisted for years. Winter extended far beyond its usual duration, lasting for 2 full years, during which the cold was relentless and unforgiving. After the long winter, the Earth endured extended droughts, leading to widespread crop failures and severe food shortages. As if these misfortunes were not enough, an unyielding plague of the deadly disease known as chuma, or bubonic plague, swept through populations, decimating communities and causing immense suffering. Entire cities, once bustling centers of human activity, fell into ruin, abandoned by their inhabitants who succumbed to disease, hunger, and despair. Civilizations proud and enduring for centuries crumbled under the weight of these successive disasters, leaving behind only ruins and memories. Yet, despite the magnitude of these events, no clear or definitive explanations emerged regarding the causes of such widespread devastation. It was a tragedy that touched millions of lives across the globe, an apocalyptic chain of misfortunes that ushered in an era of chaos and suffering on an unprecedented scale. But what exactly was the root cause of this monumental catastrophe? What forces or phenomena could have produced such a lethal sequence of environmental and health crises? The answers remained elusive for some time, buried beneath layers of uncertainty and scientific debate. In the middle of the 10th century, a significant turning point in history occurred, an event so pivotal that it laid the foundation for the world as we know it today. This period marked the beginning of what can be considered a new epoch in human development, influencing countless subsequent centuries. Over the next 5 years, a remarkable individual named David Kiss, a writer, historian, and archaeologist driven by relentless curiosity, dedicated himself to uncovering the truth behind this enigmatic episode. His meticulous research took place within the humble confines of a modest rural house, where he carefully examined various sources and assembled a comprehensive picture of the past. In his quest for answers, Kiss sought the advice of more than 80 specialists, experts in fields such as droughts, famines, floods, cosmic and environmental catastrophes, epidemics, and ancient wars. Through numerous conversations, analyses, and cross-referencing of historical documents, he explored the chronicles and annals of the 6th century AD, sourced from all parts of the world, representing diverse cultures and civilizations. His aim was to find clues that could explain the mysterious climate event that dramatically reshaped human history during what is often called the Dark Ages. Kiss's scholarly efforts culminated in a detailed and carefully researched book devoted solely to this enigmatic climatic phenomenon. He proposed that an extraordinary, unprecedented environmental event occurred during that distant era, a catastrophe so severe that it fundamentally altered the course of history. According to his research, this climatic upheaval was not mere natural variability, but a singular incident with long-lasting impacts on human societies and ecosystems alike. The core of his investigation centered on an especially intriguing mystery presented at an archaeological conference held in 1994. There, Kiss encountered a presentation that forever changed his perspective. A report by Mike Bailey, a well-known dendrochronologist. Bailey specialized in analyzing the annual growth rings of trees, a technique that uncovers detailed information about past climates and environmental conditions. In his talk, Bailey described a phenomenon unlike any before: how the widths of tree rings worldwide suddenly changed around the middle of the century. These rings, which typically follow predictable seasonal patterns, exhibited inexplicable alterations, suggesting a period of extraordinary environmental stress. Many years earlier, Bailey had embarked on a pioneering scientific journey. As a young physics student at the University of Belfast, he developed a revolutionary idea: using trees as natural chronometers, silent witnesses, recording environmental conditions over centuries and millennia. His breakthrough was the understanding that each year a tree's growth produces a new layer of tissue in its trunk, forming a ring whose width can be measured and compared. A wide ring indicates a year of favorable conditions, ample rainfall, and mild temperatures, while a narrow ring signals hardship, drought, cold, or stress. By collecting and analyzing these rings from trees in different regions, scientists could reconstruct past climate patterns with remarkable precision. Bailey's innovative approach enabled him to match ring patterns from living trees with those obtained from ancient wooden artifacts and structures, such as long-abandoned settlements and ancient ships. This process, known as dendrochronological matching, allowed researchers to establish precise chronological sequences, connecting the distant past with our modern timelines. Over 3 decades, teams of scientists and laboratories across Northern Europe collaborated to refine this technique, building an extensive database of tree ring records. They started with well-dated samples from recent centuries and gradually extended their timeline into the distant past by matching ancient samples to known patterns. This meticulous work created an unbroken, continuous record of tree growth that stretches back hundreds, even thousands of years, providing unprecedented insights into Earth's climate history. Thanks to these painstaking efforts, a comprehensive climate record has emerged, enabling us to trace environmental changes through the ages with remarkable detail. This long-term archive has revealed clear and unmistakable signs of abrupt shifts in the planet's climate. Periods of severe droughts, cold spells, and other extreme conditions that coincide with major historical upheavals. It became evident that these climate episodes were not isolated events, but part of broader, interconnected environmental patterns that profoundly influenced human civilizations. The combination of advanced technology, meticulous research, and interdisciplinary collaboration transformed our understanding of Earth's historical climate. Now, with this invaluable resource at our disposal, scientists can look deeply into the past, uncovering the intricate and often violent dance of natural forces that have shaped our world over the centuries. The story of these ancient trees and their rings helps us better understand the complex relationship between climate and history, shedding light on the profound environmental challenges faced by our ancestors and, by extension, offering lessons for our present and future. When we began studying another sample of the same tree species, which had previously attracted our attention, we were able to confirm its origin from the same parent tree. Such a connection between samples becomes evident through detailed analysis of the wood structures, which helps trace their origin and establish kinship links, reaching to the very essence and nature of the original plant. To determine the average width of each annual ring over a given period, scientists need to conduct complex and responsible analysis of numerous wood samples. This process requires the use of specialized computer programs designed specifically to process dendrochronological data using modern technologies. For example, Mike Bailey dedicated 14 years of his life to collecting and systematizing complete chronological data on ancient Irish oaks to create a unique wood chronology. Thanks to these studies, it becomes possible now to trace the climatic conditions of each individual year across Ireland over the past 715 years. Such a comprehensive analysis truly captivates the imagination. It allows scientists to study and reconstruct the climate conditions of any given year, spanning a period measured in thousands of years. All this wood data conveys not only the ecological conditions of a particular tree, but also reflects global climate changes over large geographical areas, providing access to previously unreachable information and enabling a more thorough understanding of climate variation over long historical periods. However, we, researchers, are especially interested in what could have caused, at a certain point in history, these trees to start growing noticeably taller and larger. This question becomes particularly evident during times when trees, for example, in the mid-6th century AD, experienced very difficult life periods, and their rings once again became unusually narrow, indicating harsh climatic conditions. It was precisely 10 years ago that Mike Bailey paid special attention to the fact that the rings of his oak suddenly started decreasing in width, which became a clear sign that something serious in the environment had halted or significantly slowed the growth of these trees. These signs made him wonder about the causes. What could have led to such a phenomenon during years when the rings were especially narrow, particularly in 539, 540, 541, and 542. Later, sharing his observations, Bailey described a similar situation observed by his colleague in a country located in Finland, where a significant decrease in tree growth was also noted in 536, followed by a short recovery in 537 and 538, and then another decline in 542. As a result of these data and observations, the idea of a certain pattern emerged, manifesting during specific time intervals across various parts of Europe. But this pattern was not limited to Europe alone. Connecting with other laboratories and scientific centers worldwide, David Kish discovered that trees experienced difficult times globally during the early 10th century. Analyses of annual ring structures of pines and Sierra Nevada trees in California showed that in 535, 536, and 541, some of the most drought-stricken periods of the last 2,000 years occurred, times when the climate became especially severe and weather conditions caused significant natural disasters. In Chile, in the area where Fitzroy trees grow, the most significant decline in tree growth over the past 1,600 years during the summer seasons was recorded, providing clear evidence that extreme environmental conditions could have affected the southern hemisphere as well. In the Siberian region, investigations revealed that the 20-year period of reduced tree growth observed in the 530s and 540s was the most pronounced in the last 1,100 years, confirming that even in the most remote corners of the planet, weather extremes could lead to considerable delays in the development of woody plants. Why was there such a strong reduction in growth? Was it related to global climate change, worsening environmental conditions, increased droughts, or anthropogenic factors? And finally, what caused such serious changes? The answer to this complex question was found by Michael Bailey within a microscopic study of a sample from an ancient oak dated precisely to the year 536 AD. During the examination, scientists discovered that in the tree's annual rings, usually formed in winter, there appeared a special type of cells and vessels, but already during the summer months, indicating sharp and significant climatic changes during that period. My colleague from Germany sent me a photograph of one of his oaks, showing how the tree accumulates large spring vessels and then enters a dormant state characterized by thin wood cells during the summer months. This cycle repeated year after year, creating characteristic ring patterns. What is especially important is that in 536 AD, the vessels were particularly small, and their formation occurred just before or during the summer months. Public opinion among scientists widely leans toward the idea that these changes were most likely caused by winter frosts and by alterations in the climate, which could have become extremely cold and prolonged. All this indicated that in the mid-6th century, our planet experienced an unusually cold period, the long epochs of which were recorded in the form of reduced and constricted tree growth worldwide, forming unique climate and ecological archives accessible to modern scientists through innovative research. Bailey possesses extensive archaeological data obtained from various excavations and studies in Ireland, allowing him to support hypotheses related to the characteristics of ancient times. Among these data are numerous wood samples, which he carefully dated and analyzed. Of particular importance to his work were findings derived from ancient wooden structures located on islands, which served as fortifications and shelters during times of danger, conflict, and disasters. These structures were built by people many centuries ago as defensive fortifications, and their remains are not only a testament to human ingenuity and building skills, but also important witnesses to the climate conditions of that era. For example, Bailey gained access to excavations of one such fortified site near the area of Catherine, close to the modern city of Amara. There, he carefully studied the preserved submerged logs that once formed the outer walls of this ancient fortress, since these wooden remnants could conceal valuable clues about the ancient climate and how the landscape responded to environmental changes. My own initial hypothesis about the unusual nature of what was happening arose precisely from these wooden remains, especially from those parts that had been submerged and preserved over a long period. Their age and structure indicated the influence of specific environmental conditions, potentially caused by natural calamities or climate shifts. The beginning of fortress and fortification construction in the Cranoga region dates back to the mid-2nd century AD, when, according to scientists, significant changes in climate occurred. The link between these structures and the climate crisis is considered quite probable, as harsh weather conditions and shortages of natural resources likely prompted the need to build such formidable defensive structures. Looking back, roughly 10 years, beginning from the 6th century and continuing to about the mid-5th decade, stand out as particularly difficult and eventful periods. During this time, archaeological and historical evidence suggests that weather conditions deteriorated significantly. Many sources point to an extremely low solar activity, which caused severe cooling of the climate. Crop yields in rural areas sharply declined, bread and grain supplies diminished, and many farmers began abandoning traditional agriculture. As a result, populations had to redistribute their resources. More and more people turned to fishing and hunting to secure food. This shift in lifestyle exerted heavy pressure on surrounding natural resources and on the population as a whole. Those with zapas of grain and other foodstuffs capable of sustaining them through winter likely felt quite uncomfortable and worried as their reserves were running out. Additionally, Case, a scientist passionate about studying ancient trees, was deeply concerned not only with what annual tree rings indicated, the evidence of cold winters with long freezing periods, but also with the fact that these data seemed to confirm the significant suffering of people at that time. His next goal was to investigate whether there were written sources describing the climate crisis that affected that era. In any civilization, especially in such a powerful one as the Roman Empire, the greatest and most influential culture of the 2nd century, such information was recorded. The time when Rome was destroyed by the invasions of the Huns and Gothic tribes was long gone, and now the empire was gradually rebuilding under the leadership of a new capital, Constantinople, which once again became the center of the Mediterranean cultural and political world. Turning to the knowledge of classical scholars, Kiss discovered that Roman written sources contain very interesting and instructive information regarding natural and climatic phenomena of that era. One such source is the Syrian bishop John of Ephesus, who described in his records unusual events that took place in AD 535 and 536. He recalled an event which he called a sign of the sun, a ghost unseen before and entirely mysterious. The celestial body, he wrote, became unusually dim, as if hidden, and this darkness lasted for as much as 18 months. The sun shone only 4 hours a day, and even this light was weak and feeble, like a shadow. Many eyewitnesses claimed that the previous brilliance of the sunlight would never be restored. Such descriptions implied powerful conclusions and testified to serious natural upheavals. Chronicles of the 6th century rarely mention climatic events, except for rare, particularly noticeable cases such as the appearance of comets or major natural disasters. Nevertheless, there are references in the annals to a prolonged darkness of the sun, which, according to John, occurred twice in 2 years, in AD 535 and 536, indicating widespread natural changes and significant alterations in the surrounding atmosphere. In his records, John explains that spring in those years was devoid of its usual softness, and summer was especially cool and lacking warmth. Months that typically signified harvest ripening were affected by northern winds, which strongly cooled the air. Long periods without rain made winter very dangerous and unpredictable, as the threat of frosts remained high. Reapers working in the fields feared new frosts that could destroy the last harvest. All these events occurred in the Mediterranean region, an area surrounded by ancient civilizations, including Babylon, Egypt, and other centers of culture and trade. Significant in these years were the events in the Near East, which were also unusual and related to global climatic changes. In the modern world, when we begin to consider how ancient civilization developed, a natural question arises. What was happening in other regions of our planet at that distant time? In search of answers to this question, I decided to turn to various historical records preserved from northern and southern parts of China, as well as from Korea and Japan. These sources, more than 30 in total, are scattered across various chronicles, annals, and ancient manuscripts, among which I identified about 12 that directly or indirectly mention events related to dark forces, the sun, and their climatic consequences. These texts allowed me to trace the connection between natural catastrophes and environmental changes of that time, which was particularly valuable for my research. For example, in the year 65 AD, a well-known Japanese emperor who was ruling the country at that time remarked, "Food is the foundation of the empire," implying that providing the population with sustenance was a task of paramount importance. He understood that no wealth, whether gold reserves or riches expressed in 10,000 strips of silk, could save one from starving death if the harvest was not gathered and the land did not yield enough fertility. Just how vital food was is also demonstrated by other ancient records. No matter how wealthy a state was, whether they accumulated thousands of boxes of pearls, in times of famine, all those riches proved powerless. Those suffering from cold and deprivation often wondered, what good are riches if you are dying of hunger? Similar sentiments were expressed in the chronicles of South China, especially in small reports describing the events of that time in detail. It was noted that in the southern regions, yellow dust fell from the sky just as copiously as snow, and it could be scooped up with hands, not for use, but simply because it was the only thing left in sight and carried away by the wind. The deeper I delved into studying the historical sources, the clearer it became that this catastrophe affected not just one or two regions, but literally the entire planet. It was not confined to local natural disasters, but manifested almost everywhere, from remote villages to major cities, leaving a memory in chronicles as a globally scaled event. Only one question remained: what caused such a widespread calamity? In my reflections, I outlined 3 possible explanations. The first, the most popular among scholars, is a collision of Earth with an asteroid. It suggests that a massive object passing by or crashing down released an enormous amount of dust and debris into the atmosphere, triggering serious climate changes. The second possibility involves a comet, which, due to its initial structure and movement across the sky, could also have contributed to environmental destruction. And finally, the third explanation is a volcanic eruption, as volcanic activity at that time could have been so intense that the ash and smoke released into the atmosphere blocked sunlight for many years, causing a prolonged winter and famine. Imagine the horror that gripped the world in the mid-6th century AD, when such events led to a true climate catastrophe. Trees that usually delighted the eye with their greenery and promised fertility nearly ceased to grow for several years, and the sun barely pierced through a thick veil of dust and fog. To cause such a prolonged winter that could last an indefinite period, thousands of cubic kilometers of fine dust had to enter the atmosphere, covering the entire world and hindering the penetration of sunlight. Researchers continuing studies of this period still debate the nature of this phenomenon. Was it the result of a strike by a steel asteroid, a cosmic comet, or perhaps the eruption of a massive volcano? However, evidence of large-scale climate catastrophes is confirmed by numerous finds. They show that such events occurred earlier and left their imprint in the geological record. Note: modern studies examine the consequences of these natural disasters, even analyzing changes in the atmosphere caused by major collisions of cosmic objects and nuclear explosions. At the site where the atomic bomb was later created, scientists found signs indicating severe stress impacts on the atmosphere, believed to be caused both by collisions and the emergence of nuclear energy, which could be used not only for peaceful purposes. Many facts confirm that Earth was regularly struck by both large and small meteors and comets, evidence of constant cosmic threats that periodically interrupted normal life on the planet. To trigger a global climate catastrophe, a collision with a large celestial body was necessary. Such objects vary in shape and size, and their characteristics determine the scale of potential destruction. Meteors are small stones and debris moving through space, sometimes falling to Earth's surface. Usually, their fall causes minimal damage, perhaps a small crater and a faint light phenomenon. Asteroids are larger cosmic stones that, upon colliding with Earth, explode in the atmosphere, forming powerful clouds of dust and debris capable of altering the planet's climate if such collisions occur too frequently. Renowned astrophysicist David Kess, who dedicated his life to studying celestial bodies, performed calculations to determine the energy required for a collision that could cause a climate catastrophe lasting at least 10 years. His research showed that after such a collision, approximately 1,000 particles per cubic centimeter should accumulate in the atmosphere, which is a critical threshold for causing global changes. To achieve such an effect, a collision with an asteroid at least 4 kilometers in diameter was necessary. In the case of a comet, its impact could have been even more destructive. Unlike a solid asteroid, a comet is primarily made of gas and ice, so its collision and impact on the climate could have been even more significant. Thanks to its less dense structure, a comet is capable of leaving a long tail, clearly visible in the sky, and traveling along a trajectory that could potentially cause the most severe effects on Earth. The renowned astrophysicist Anne Fitzsimons estimated that a comet about 6 kilometers in diameter would be needed to induce a substantial change in the global climate. This means that the size and structure of cosmic objects play a crucial role in determining the magnitude of possible catastrophic consequences for our planet. Thus, All these considerations and studies form a complex picture of the causes and mechanisms behind ancient climate crises, demonstrating how sudden and destructive impacts with cosmic bodies could be, and the large-scale consequences they had for humanity and all of mankind. Such a collision of a cosmic object with our planet could have catastrophic effects, capable of altering the course of history and leading to a global disaster. Imagine a scenario where such an asteroid approaches Earth. Its detection would occur relatively late, less than 2 days before the anticipated encounter. During this short period, it typically appears in the sky as only a faint star, barely noticeable in the dark abyss of the night sky. At this moment, it blends into the background of starry darkness, making it difficult to observe without specialized equipment or careful monitoring. However, the closer it gets to Earth, the brighter and more noticeable its irregular light becomes. About 30 minutes before the potential impact, it reaches its peak brightness, transforming into the only bright point that captures the gaze and draws the attention of everyone looking at the night sky. Likely, at that moment, a large number of astronomers, as well as ordinary observers, first notice it, realizing that this bright object is approaching Earth at incredible speed. Unfortunately, to date, we lack technologies or methods capable of fully preventing or adjusting the trajectory of asteroids or comets heading toward Earth. Astronomical forecasts can provide approximate estimates, but completely eliminating the potential threat remains beyond our current capabilities. The time it takes for such an object to travel from the upper atmosphere to the level of the ocean or land is only about 8 seconds. During this brief period, the asteroid covers vast distances, reaching the surface and transforming into a bright, fiery ball, striking the Earth at such a speed that the sound resulting from this collision would not have time to reach us. In fact, a meteorite traveling at roughly 20 times the speed of sound hardly produces any audible signals when entering the atmosphere. Only a few minutes after we observe a bright flash or a dazzling light, might we hear the first sonic booms, if they even reach us at all. At the moment of sudden atmospheric entry and collision with the Earth's surface, the asteroid would instantly transform into a fiery ball, vaporize, and leave behind a massive fire and a catastrophic wave of heat. Could such a disaster have gone unnoticed and unrecorded by all existing civilizations and cultures? This is unlikely, since even if such a powerful impact had occurred, its consequences would leave obvious traces in the Earth's geological layers. There is no evidence in human history or archaeological discoveries of a mass catastrophe of such a scale that could have taken place around the first centuries of our era. Moreover, since the 10th century, geological studies have not found any signs of a crater or other collision indicators that could be linked to a large asteroid or comet from that time period. From a geological perspective, such an event would appear as if it had occurred just yesterday. An enormous crater, with lasting climate and landscape changes permanently recorded in the Earth's strata. Of course, we know that in the distant past, approximately 65 million years ago, dinosaurs faced extinction precisely due to a collision with a large asteroid or comet. However, I do not believe such an event could have happened in the 6th century AD, as there is no confirmation of that. The absence of signs of a significant impact in the geological layers, such as the lack of corresponding craters and alterations in fossilized remains, supports this. Nevertheless, it cannot be ruled out that the impact may have occurred in a water body on our planet. Given that about 70% of Earth's surface is covered by ocean waters, there is a possibility that the collision took place there. In that case, the first thing we would have felt at the moment of impact is a powerful tsunami, potentially reaching heights of a mile or more. This would mean an enormous wave capable of flooding coastlines hundreds of miles inland and causing devastating effects over vast regions. These waves continually move, penetrating deep into continental interiors, raising water to great heights, and inflicting irreparable damage on coastal ecosystems and settlements. However, an analysis of archaeological and botanical data shows no signs of such impact affecting coastal plants or seabed sediments, indicating that no event of such magnitude and suddenness as an asteroid strike in the ocean occurred. The absence of traces of significant tidal waves leads to the conclusion that such an event is unlikely, or at least has not been confirmed by scientific research. Additionally, in the search for compelling evidence of such a natural apocalypse, scientists focus particularly on signs of volcanic activity that could indicate a catastrophic situation. Volcanic activity was often associated with major calamities, caused either by a cosmic collision or internal geological movements of the Earth. However, in this case, no substantial traces of volcanic activity have been found that could suggest global changes in climate or landscape at that time. Nonetheless, there are some hypotheses and alternative explanations related to extraterrestrial phenomena, which are frequently considered in scientific circles. According to one such theory, proposed by scientists Mike Bailey and David Kessy, rather than a single large impact, this period involved numerous small fragments or shards that dispersed in the atmosphere and kind of scattered across the sky and the Earth. This concept is based on a model in which large fragments from disintegrating comets or asteroids are heated in the atmosphere, causing powerful explosions and fireballs. A classic example of such events is the fall of the Tunguska comet in 1908 over Siberia. As a result of this powerful explosion, occurring at an altitude of several kilometers above the ground, a shockwave was generated that destroyed trees and caused significant local damage. An explosion approximately equivalent to 20 megatons, based on estimates, became one of the few cases where the phenomenon of an exploding object in the air was clearly documented and studied. This event serves as a good illustration of the power of an explosion, resulting from entry into the atmosphere of a not very large but still sufficiently powerful cosmic body, which detonates in the air, leading to extensive destruction over a local area, creating a massive shockwave and fires. At the beginning of his research, Mike Bailey faced an important and simultaneously very challenging task: to find microparticles capable of influencing the planet's climate processes. Encountering a deficiency of such tiny particles, the scientist pondered possible reasons for this phenomenon. He hypothesized that stories and myths prevalent in legends might contain clues that could help explain how a significant climate catastrophe could have occurred in ancient times. Consequently, Mike Bailey began actively studying mythological sources, convinced that they might hold the key to solving this enigma. As the main subject of their research, they chose one of the most famous legends of all time, the story of King Arthur, which holds many mysteries and parables related to the fate of the people and nature. Historical legends claim that in the 6th century, a mighty and renowned king named Arthur ruled over Britain. Later, mythological tradition reinforced the idea that he lived in the western part of the island, and over time his kingdom gradually turned into a barren, lifeless wasteland. This period is considered one of the most tragic in British history, and the dates associated with Arthur's life and death particularly interest historians and researchers. Legends suggest that the king died either in 539 or in 542 AD, specifically at the end of the 5th or beginning of the 6th century. This period corresponds to the classical date of a climatic catastrophe, which, according to legends, was accompanied by heavenly strikes falling upon the earth with devastating force, almost as if nature itself was displaying its wrath. Interestingly, these legendary events might have been caused by a comet collision, which inflicted significant damage on the ecosystem and altered the landscape and climate of the region. Mike Bailey suggested that the death of the legendary King Arthur could symbolize destruction caused precisely by a celestial body, a powerful comet that, upon impact left widespread devastation. Considering that legends often contain encrypted knowledge and metaphors, it is possible to surmise that they hide evidence of ancient natural catastrophes. For example, in myths about Arthur and his era, there are images, such as a bright solar deity, or a figure with a long arm that may resemble a bright comet tail shining in the sky. Furthermore, in Celtic mythology, there exists a character known as God Lucas, depicted as a deity of sunlight appearing from the west, possessing a long, extended arm often associated with meteor or comet falls. This imagery may hint at the destructive power of astrophysical objects, as Lucas is known for his destructive capabilities. Thus, the myth of Beli, or other similar legends, may not merely be artistic fiction, but could contain encrypted reflections of real natural events related to powerful celestial impacts. Modern scientists, closely studying these myths, have concluded that their content can be summarized by two main hypotheses. Either the catastrophe was caused by a bombardment of Earth with meteors or comets, or by a large volcanic eruption, which also led to severe climate changes. However, to confirm or refute either hypothesis, scientists sought additional evidence of these events and delved into mysterious layered deposits of the Earth. In this context, David Kise, one of the renowned geologists and researchers, discovered another important source of information: the polar ice caps, which accumulate layers upon layers of data about past climate epochs. Over the past decades, international scientific teams have undertaken large-scale expeditions to extract multi-meter ice cores from Greenland in the north and Antarctica in the south. The process of such extraction is similar to how trees annually form new rings, reflecting the environmental conditions of a particular year. Each layer of ice contains unique chemical and physical indicators that allow scientists to understand what was happening with the atmosphere and climate during that era. By examining these layered formations, scientists find that they record precise changes in the chemical composition of the air associated with global catastrophes. For example, the appearance of rare elements like iridium in the layers can indicate the impact of a large celestial body, as this element is linked to meteorite events. Similarly, an excess of sulfur compounds serves as a sign of intense volcanic eruptions that could have released vast amounts of sulfates, surrounding the Earth with a dense cloud and causing climate cooling. The process of these layered deposits occurs as follows. During powerful volcanic eruptions, a large volume of gases and ash is released into the atmosphere, capable of traveling thousands of kilometers through the air, reaching polar regions and settling in the form of ice layers. These traces are preserved in the ice, maintaining a record of climate changes over millennia. Therefore, by analyzing these annual layers, scientists can accurately date events and determine whether a cosmic impact or volcanic activity was the cause of a global crisis. Recently, Professor Hammer's team managed to extract from the Greenland ice depths a sample dated to approximately 530 BC, that is, about 530 years before the Common Era. This discovery marked a significant step toward understanding the causes of one of the most mysterious climatic catastrophes of antiquity. By studying such a sample, scientists hope to identify possible signs of a cosmic explosion or a sudden volcanic ash eruption in its composition, which in the future could help us understand what exactly led to that series of natural disasters that changed the course of history and left behind legends that have survived for centuries. To begin working with this material, it is necessary to perform a thorough preliminary cleaning to remove any potential foreign impurities and unwanted elements that could hinder further analysis. Afterward, the prepared ice sample should be carefully placed into a specially designed device where it will undergo multiple stages of meticulous processing from all sides. This will allow detailed examination of every tiny detail and ensure the most precise investigation. The next step involves carefully cutting the sample with a finely sharpened steel knife, while exercising particular caution to avoid damaging the internal core and disrupting its structure. During this process, it is important to remove large amounts of ice, as external contaminants and foreign inclusions must be eliminated to ensure the purity and accuracy of subsequent results. The cleaned core will then be cut into small pieces exactly 5 centimeters long, making it convenient to place them into melting and analysis devices. Each piece will be melted, followed by a series of precise measurements to determine its chemical composition and the concentration of various substances. In later stages, all measurements will be performed automatically using specialized equipment, and the obtained data will be displayed on the screen of a simple but informative computer as chromatograms. Graphical images showing the distribution of substances within the sample based on their concentrations. What might we expect to find on these charts? Perhaps traces of mysterious cometary debris or sulfates typical of volcanic eruptions. Pay particular attention to the dynamics of sulfate levels. It is noticeable that the peak for these compounds increases with each new sample, which is a significant indication of the presence of sulfuric acid in the atmosphere. This, in turn, suggests that intensive volcanic eruptions were occurring at that time. Remarkably, the overall analysis shows that it was not a simple eruption, but an event that significantly influenced the climate situation. The visually displayed concentration data of sulfuric acid indicate that its level exceeds all other indicators recorded in this area of study. Records of this event clearly point to it occurring approximately a year ago, undoubtedly confirming the scale of the eruption. The data obtained from cores taken from Greenland are quite convincing. Many sulfate residues are also found there, but no traces of cometary particles or fragments have been detected. Nevertheless, to conclude that this eruption impacted the global climate, additional supporting evidence is needed. To clearly understand the scope of its influence, traces of it must be identified in both polar regions, the Antarctic and Arctic ice cores. Currently, only less precise data from Antarctic samples are available. However, a team of scientists led by Professor Hamer has already identified signs of a volcanic signal, specifically in Antarctic layers. It should be noted that this signal was recorded over several years, which suggests a prolonged and large-scale eruption. Similar evidence has been found in ice cores from Greenland, although the age of these samples is not always precisely determined. However, their presence confirms that a powerful volcanic event occurred at a certain point in time. Analysis of data collected from both poles indicates that in the mid-20th century, there was a significant increase in the emissions of sulfur compounds into the atmosphere. This fact suggests that volcanic ash and gases released into the atmosphere became a cause of global climate changes. Tree rings associated chronologically with this period unequivocally attest to large-scale climatic fluctuations driven by this very event. It is quite surprising that nowadays the idea that volcanoes can lead to climatic catastrophes is not always taken seriously. However, numerous studies based both on tree ring analysis and ice core data show that roughly once every 1,000 years, global climate changes occurred, and one of the most prominent manifestations was the event of the mid-6th century, which proved to be extraordinary in scale. But the particularly striking statistics relate to eruptions over the past 100 years. It is often forgotten that the current century is one of the most, if not the most, peaceful in terms of volcanic activity in human history. Looking at historical sources and chronicles, one can note that in the X and Second centuries, there were many powerful eruptions occurring in groups approximately every 20 to 30 years, indicating almost a volcanic epoch characterized by a series of catastrophic events. Many of these volcanic eruptions were so destructive that their effects were felt far beyond the localities where they occurred. Volcanic emissions reached the stratosphere, creating giant ash clouds that, in their scale and strength, sometimes surpassed all previously known natural phenomena. These eruptions could mix in the atmosphere, forming unique and often fantastical landscapes, as if created by an artist's hand rather than nature. During that time, people often looked at unusual bright sunsets with fantastic shades of red and orange, and many believe that artist William Turner, a master of vivid colors and dramatic scenes, depicted such atmospheres. But in reality, during Turner's era, such sunsets looked roughly like this: saturated and flaming, as if blood red. For many centuries, our planet has counted over 20 active volcanoes, which often remain dormant but can suddenly awaken and produce powerful eruptions. Despite their relative calmness in recent times, one large and powerful eruption could significantly affect the climate conditions of the entire Earth. To form a gigantic ash cloud covering the entire globe in the atmosphere, it must be ejected by an eruption occurring somewhere near the equator. It was in this region that wind forces were most effective in transporting dust to both hemispheres, overlaying the global weather systems. Currently, there are more than 90 volcanoes located along the equatorial area that could potentially be sources of such powerful eruptions. But a fair question arises. Could such an event have taken place in the 9th century? And which of the active volcanoes was responsible for the global climate changes at that time? In seeking answers, it is especially important to understand which of them could have produced such a massive eruption and how its activity might have been recorded in historical sources. David Kiss, a specialist in geological and climatic issues, took on an important task: to narrow down the list of possible volcanoes capable of causing the tragic events known as the 9th century event. He knew that the highest concentration of large tropical volcanoes was focused in a curved region located southeast of the Asian continent. This arc extends across India and Sumatra, continuing to Java and the Philippines. That was where he decided to focus his efforts in search of the source of the destructive events of the past. As a key to unraveling his historical puzzle, David turned to the rich, written tradition of that era, which remained one of the most advanced civilizations in the region, in ancient China. He knew that Chinese culture in the 9th century left numerous records that could shed light on the mysterious events that took place over 1,000 years ago. Excited, he began studying ancient chronicles and historical documents, hoping to find references to a time that continued to stir the minds of scientists and researchers long after. And so, in February of the year 1600, Chinese historians recorded an extraordinary and exceedingly loud explosion, accompanied by roaring sounds coming from the southwest. These sounds, very clearly described in the annals, coincided in time and place with the presumed eruption, which could have been caused by one of the region's largest volcanoes. Unexpectedly for the researchers, these records did not mention lightning or other natural phenomena usually associated with eruptions. It was only stated that a thunderous noise emanated from the region, rich in volcanic activity, the central part of Indonesia. The most surprising aspect was that this peaceful description was unusual for the Chinese. They seldom documented such sounds and phenomena without signs of a catastrophe. The chronicle described the sound as resembling thunder, resulting from a powerful volcanic eruption. But a question arose. How could this have happened? Can the sound effect from a volcano eruption located more than 3,000 miles away reach such distant China and leave such a detailed record in the annals? In response to these questions, David, together with scientists, contacted the Los Lomos laboratory located in New Mexico, where they were explained the physical principles of sound propagation over vast distances. They described that during powerful volcanic eruptions, a shockwave is generated, which spreads rapidly through the surrounding area, producing a loud and audible rumble at close range. However, as the sound travels through space, its high frequencies diminish, causing the signal to transform into a lower, longer-lasting, somewhat faint but still rumbling noise. These low sounds, recorded at the Infrasonic Institute, typically have frequencies below 10 cycles per second and easily penetrate atmospheric layers, reaching even the most distant points. In this case, this rumble, reminiscent of a distant thunder echo, could very well have been heard even on the opposite side of the world. Experts from the Los Lomos laboratory likely consider such an explanation quite plausible and hope to find written sources left in Indonesia at that time that could confirm their hypothesis. However, available chronicles describing those events are extremely scarce, as very few written records from the region have survived. Nevertheless, the researchers uncovered a deeper trace in history. They found an important clue in documents stored in the Royal Palace of Solo, located in the center of Java Island. There is an extensive collection of handwritten chronicles, once known as the Book of Kings, a unique source of information about past eras, left behind by illustrious rulers and priests of that time. This ancient collection could be key to unraveling the mystery linked to a powerful volcanic event, which is reflected in the region's history and potentially in the Earth's global climate record. Despite being compiled and recorded in the distant 19th century, specifically in 1850, it contains information based on truly ancient sources, studied and transmitted through generations. Its entire essence revolves around an astonishing event that occurred approximately in the middle of the first millennium AD, around the 5th or 6th century. Modern researchers and historians, engaged with archives and ancient manuscripts, often regard these ancient records as invaluable sources, shedding light on the most significant events of bygone days. In particular, one of the royal archivists, Prince Puja, a brave and thoughtful researcher, is currently engaged in a careful reading of the original text titled The Mighty Thunder. It is he who, armed with a rich historical background and a keen understanding of ancient manuscripts, compares them with contemporary data. In his understanding, the plot of this source is filled with vivid descriptions of natural disasters, fierce retaliatory strikes of the earthly element, the dull darkness looming over the world, mysterious thunder and lightning tearing through clouds with terrible force. As a result of this natural chaos, a mighty storm broke out, a truly fierce and destructive wrath of the element. Following this, the ground was flooded with the most powerful rain, transforming the weather into a deadly tempting threat, and the entire surface of our world was covered by a tornado. A storm that not only overwhelmed it with its power, but also turned it into impenetrable, deaf darkness, where it seemed everything was disappearing. Soon after this catastrophe, something incredible happened. A great flood occurred in an instant, or in other words, a great deluge that swallowed everything in its path. After the water levels gradually receded from this catastrophic flood, a remarkable scene appeared before the eyes. Java Island, previously connected to other parts of the land and surrounded by the ocean, was now split into two parts. As a result of this fracture, a new island was formed, Sumatra, vast and significant in size. During this natural collision, keys, or according to ancient testimonies, mysterious sources of rich gold-bearing deposits, disappeared, containing all the value and wealth of ancient civilizations. It was in these depths that the books of the kings, sacred manuscripts reflecting the history and authority of ancestors, were carried away behind their borders. In the modern era, geophysical scientists discussing these events confirmed that such descriptions would fully align with what is known about powerful and destructive volcanic eruptions. They indicated that the event in question was a large volcanic explosion that could have occurred precisely during the period described in ancient sources. Precise geophysical data and modern research confirm that, most likely, we are talking about a large-scale eruption, similar to those occurring during strong volcanic catastrophes. However, one question remained about which volcano exactly was mentioned in the Book of the Kings. There was a hint that in this region, located between Sumatra and Java, there is a single large volcano that thundered threateningly and erupted with particular force. This volcano was called Krakatoa, known to the whole world as the most famous active volcano erupting in human history. Its most recent powerful eruption occurred in the 18th year of the 1700s, specifically in 1783, and it drew special attention, causing global consequences and the death of many people. The question that remained open for scientists was only one. Could the very keys mentioned by ancient sources confirm that the culprit behind all this was precisely Krakatoa? Part 20 of 48. In this complex and mysterious story, a volcanologist, a professor from Iceland named Halldór Sigurdsson, was also involved. Currently working in the United States, he is well versed in the features of volcanoes and has visited Krakatoa multiple times to study it more closely. He was convinced that this volcano concealed an ancient secret, linked to an eruption that occurred long before the events recorded by modern sensors and observations. 5 years ago, while conducting an expert analysis and studying the 20th century Krakatoa eruption, he encountered a particular clue in his investigations, suggesting that there might have been an entirely different, much larger and more powerful eruption that predates what we previously knew. At that time, he said, they lacked both the time and resources to fully determine what exactly had happened in those distant years. For this reason, their primary task became finding fossilized remains of charcoal that could be present in the rock layers, both below and above the supposed date. This created an intriguing scenario. If they could determine the exact date of this supposed eruption, they could understand its scale and strength. Professor Key's ideas, as well as his theories, turned out to be crucial for this research. They were so innovative and unusual that the team, switching to a new information channel, decided to fund an expedition specifically to test these hypotheses. The main objective was to verify whether a powerful eruption really occurred in those distant years, and whether Krakatoa itself was responsible for this ancient catastrophe. Krakatoa volcano is part of an archipelago of small, uninhabited islands covered in tropical forests, located west of Java, just south of the equator. This archipelago became famous after its catastrophic eruption in 1773. This eruption was the most extensive known and documented in recent years. It resulted in the death of 36,000 people on the mainland and in coastal areas. During these investigations, the professor and his team decided first to visit Anak Krakatoa, which means Child of Krakatoa. This island emerged entirely after the eruption in 1773 and rose about 200 meters above sea level. Each subsequent wave of volcanic activity caused it to become even taller and more dangerous. Over the years, the island has already reached a height of 1,000 feet and continues to grow, making its peril increasingly apparent. From the very first moments, it is clear why this is happening. From the depths of this volcano, as it approaches, enormous stones are ejected, sometimes reaching 5 or 6 meters in diameter. These stones are propelled into the air with enough force to injure an enemy. They fly like projectiles and leave behind craters. One of these craters, for example, reaches a depth of 2 meters and a width of 4 meters. All of this serves as a cause for concern and indicates that the danger of this island and its volcano is becoming particularly significant for the surrounding area. It is truly a unique and grand natural phenomenon, embodying the incredible power of the Earth. Imagine a massive boulder hurtling through the air at high speed with a tremendous crash, and upon reaching the ground, creating an unbelievably deep and impressive crater. This crater, like a giant wound on the surface of the planet, becomes a reminder of how unpredictable and wild the forces of nature can be. At the moment of the explosion, standing at a safe distance, you could take cover behind this massive stone, experiencing its protective function, which at that moment would seem almost impossible. We hope that today such stones do not fall too close to populated areas or important sites, as their fall represents an extremely dangerous event. However, it should be noted that just 2 hours after the team departs from the site, these stones, often saturated with lava, begin to show activity. Small stone fragments start to dislodge and burst into the air, with explosions, and hot lava rises from the depths of the ground, ready to continue destroying everything in its path. An unusual sight, from a safe distance on the surface of the sea or along the coast, watching this powerful spectacle, like a grand festival of fire and stone, offering indescribable impressions even amid the threat. Undoubtedly, this is only part of the vast centuries-old cycle ongoing on our planet for hundreds of thousands of years. From the depths of the ocean waters, the Krakatoa volcano rises slowly but steadily, shaping its form. Every time it erupts, it adds new layers of rock, and over time the island grows larger and larger. But eventually, after numerous powerful eruptions, it will unavoidably collapse. It will spontaneously disintegrate, losing its stability and giving way to new formations. This time, throughout the night, the island was discussed and bombarded with various stones and lava, a kind of constant theatrical display. By the following tropical morning, the earth and air were filled with a hot wave of heat and clouds of dust hanging in the air like a dense veil. The atmosphere tightened, reminiscent of the fact that natural forces are fearless and unpredictable. Our task is to imagine a journey through time that allows us to look back hundreds of years, long before the Krakatoa Island appeared on the surface. For it was then, in the distant past, that the most important transformations of this region took place. One can only speculate how this island formed over the decades, perhaps through a series of consistent small eruptions leaving behind layers of lava and rocks. Scientists believe that throughout history, it has held secrets hidden for centuries upon centuries, and its story is filled with mysteries. By examining old illustrations from the year 1920, one can imagine an approximate picture of how this recent geological stage looked. At that time, the ancient Krakatoa still existed, which, according to experts, erupted about 535 years ago and left behind an archipelago of islands. Over time, with infrequent and somewhat smaller volcanic eruptions, the islands gradually regained their shape, and by the year 1843 AD, they had grown back into relatively large landforms. This, in turn, led to a new powerful explosion, which ultimately formed the modern islands known as Krakatoa, or alternatively, the Krakatoa Islands. Recent studies of this region, carried out by a scientist named Sigurdsson using modern technology, confirm this very hypothesis. 5 years ago, he created a detailed map of the ocean floor with a special device called a sonar, which allows precise determination of underwater structures' contours. The maps produced during this expedition reveal the outlines of a massive caldera crater left after a powerful volcanic eruption. Among its features is a circular structure, significantly larger than other underwater formations, suggesting that this giant caldera is evidence of the ancient volcanic activity of Krakatoa, hidden beneath the water surface. Currently, scientists are seeking a way to precisely date the moment when the massive explosion of the ancient Krakatoa occurred to understand how much time has passed since then. Finding proof is crucial. Primarily, charcoal resulting from when moist, hot lava instantly burns trees nearby the erupting volcano. This charcoal can be dated through radiocarbon analysis in a specialized laboratory. However, locating these samples is an extremely challenging task. as the charcoal may be found in layers to the left or right of the presumed eruption zone. And it might be scarce or difficult to access, especially within extensive geological debris. If the search for this charcoal in the targeted layers fails, scientists will be able to narrow down the time frame by studying layers above or below where the material might also be present. This process is compared to searching for a needle in a haystack, and despite its difficulties, it is necessary to obtain accurate and convincing data. Currently, I am in the very center of a large mass of periclastic deposit formed as a result of the most powerful eruption of the ancient Krakatau. This rock was likely formed in the 6th century AD and reflects the rapid processes that took place deep within the Earth at that time. My task is to carefully extract a small sample of charcoal from this layer so that scientists can determine the age of this significant event, shedding light on the history of the formation of the modern Krakatoa and its centuries-old mystery. If we happen to find charcoal within the layers we've discovered, it would be a real breakthrough and a step that could substantially bring our research closer to solving long-standing questions. I am ready to devote maximum effort to thoroughly understanding all the nuances and details related to the possibility of finding this important archaeological artifact, because we have extensive data on soil layers infused with mysterious history. The centuries-old layers of Krakatoa cover an incredible span of time, hundreds of thousands of years, and even a detail such as the age of a major ancient eruption, presumed to have occurred just a few thousand years ago, would be a significant breakthrough for us and help us better understand the timing of this event. Sometimes, searching for charcoal turns into a real challenge. It is not as simple as it seems at first glance. You might think that since we are dealing with charred remnants of trees, they would be easy to find in the tropical climate, where vegetation prospers and remains easily recognizable. However, in reality, the situation is more complex. Many volcanoes in this area remain almost deserted because continuous volcanic activity creates an inhospitable environment for the establishment and growth of forests. Therefore, searching for charcoal in this location is not only difficult, but also limited in area. It's worth noting that only a small part of Krakatoa Island extends above sea level, which significantly reduces the available space for excavations and research. During the 2 weeks spent in this mysterious territory, Professor Sigurdsson managed to collect only 10 charcoal samples. These samples were too small to precisely determine the eruption date based on their age, which became a problem. He was unable to obtain a large enough sample to conduct radiocarbon dating of the layer corresponding to the main eruptive events. However, despite this, he managed to obtain good samples from the layer located slightly above, the layer associated with the post-eruption period, as well as from several layers below. Our plan is to determine whether the year 1000 AD falls within this dating interval, because the confirmation or refutation of the hypothesis proposed by David Keyes depends on it. If the date 535 AD does not match the results obtained, then our main theory regarding the timing of the major eruption will be called into question and will need to be revised. 6 weeks after the radiocarbon analysis is conducted, the results obtained in the laboratories will be ready and sent for review by specialists. Professor Sigurdsson will email the final data to David Keyes, along with the corresponding report, giving us the opportunity to take another vital step toward uncovering the truth. And this is truly encouraging. It turns out that the layer directly above the major eruption layer dates to 2000 years AD, while the layer just below, lower than the previous one, has an age of 600 years BC. A more detailed analysis of these facts reveals the following picture. The topmost layer is a modern deposit, dated to 1915 AD, while the adjacent layer directly beneath it is associated with an eruption event, roughly 1000 years BC. Then there are approximately 5 more layers, with the lowest one being a layer of charcoal, dated to 6000 years BC. This indicates that the development and accumulation of these deposits occurred over a very long period, and the volcano's age is likely several thousand years. Based on this, a logical assumption arises that the significant and well-known eruption event discussed took place much closer to a period, roughly 1,000 years ago than in the era 6,000 years BC. However, it cannot be completely ruled out that the eruption in question occurred either around 600 years BC or within the interval up to 300 years after zero. All of this leads us to conclude that the time frame covered by our data spans from 6,000 years BC to approximately 1,000 years AD. As a result, David Kies believes that the Sven's period, during which a major eruption occurred, pertains precisely to the first millennium AD. Its time frame, according to scientists, could range broadly, from 600 years BC up to 500 and even the year 1000 AD. However, thanks to the evidence collected and analyzed, this range has been significantly narrowed, making it more precise and concrete, from 0 to 1000 years AD. In this context, the year 1535 becomes the center of this timeline, which, in my opinion, appears quite promising and supports our hypothesis regarding the approximate dating of the major eruption and the related event. 5 long years of painstaking research, analysis, and discussion. This is how much time David Kies needed to gather and systematize convincing evidence, supporting his theory about the global natural cataclysms that occurred in the distant past. As a result of his work, irrefutable evidence emerged indicating that, around the 5th century AD, a truly massive volcanic eruption occurred in the tropical regions of the planet, forever changing the course of Earth's history and climate. Among all potential culprits of this natural disaster, the most likely and best supported by evidence is the famous and undoubtedly the most dangerous volcano, Krakatoa, located off the coast of Indonesia. If these hypotheses are correct, this event marked the beginning of a chain of large-scale climate changes, which led to the most impressive and dramatic effects in the history of our planet. The eruption, triggered by this long-awaited and essentially fate-changing event, produced a huge cloud of ash and smoke that blocked the sky around the globe for many years. The rising column of ash and dust reached a height of approximately 30 miles, about 50 kilometers, creating one of the most spectacular and dangerous natural phenomena in human history. Such a cloud, resembling a gigantic demonic umbrella, concealed the bright sun and cast it into shadow, resulting in daylight fading into impenetrable darkness. This dark sky and dense fog caused by the ash eruption inevitably led to a severe climatic reaction. The atmosphere cooled significantly, a so-called nuclear winter effect caused by the vast amount of dust particles blocking sunlight. Temperatures dropped so low that summer months turned into cold winters, and crops failed to mature in time. Subsequently, drought followed because plants and agricultural crops could not perform photosynthesis without sunlight. All of this created conditions of hunger and disease for millions of people living at the time. Such a global climatic upheaval associated with a major eruption had a profound impact on the course of human history. According to modern scientific data, it was precisely in the year 535 AD that an eruption of such scale took place. The volume of volcanic material and ash released into the atmosphere was so great that weather anomalies persisted across entire seasons, causing cooling and a decline in agricultural production. As a result, the Earth appeared to plunge into a prolonged cold and food shortages, leading to widespread suffering and death. Millions of lives were destined to be lost to famine and illnesses caused by the climate crisis. Over the past 5 years, David Kies, a well-known and respected scientist in academic circles, historian and archaeologist, has paid particular attention to studying this massive climate catastrophe. His research has focused on identifying the causes and consequences of this event, consulting with numerous specialists for insights. Among them were professional historians, scientists studying ancient times, and especially volcanologists specializing in the study of volcanic eruptions and their consequences. This interdisciplinary approach allowed Kiss to draw quite definite conclusions. Ultimately, he became convinced that the main culprit of the global climate upheaval was the famous and dangerous volcano, Krakatoa, located in the Indonesian archipelago. To confirm his hypotheses, he organized an expedition to Krakatoa Island, during which, thanks to research and collected materials, he was able to reaffirm his theory. The expedition demonstrated that this volcano was the source of the catastrophic eruption of the 5th century. However, Kiss is sure that the power of this eruption, the largest in the past 1,500 years, was only the starting point for a series of subsequent tremors. Over more than a century after that eruption, numerous geological shifts, earthquakes, eruptions, and climate reactions occurred, forever changing not only the natural world, but also the fate of human civilization. A logical question arises. What could the scene of the eruption itself have looked like? This grand event that happened more than 15 centuries ago. What unfathomable and immense forces were revealed in that epic moment? The energy released during this event, according to experts, was roughly equivalent to 2,000 nuclear bombs. The very bombs dropped on Hiroshima in 1945. One can imagine the power and destructive force inside the Earth's depths that had to be endured in those distant times. Krakatoa's eruption in those days was an event incomparable to any other recorded by humanity. It was, apparently, many times, possibly hundreds of times, more powerful than any other volcano in recorded history. I approached volcanology specialist Dr. Ken Welez to obtain the most complete and accurate information. He requested that all available archival data on climate changes of the 6th century be uploaded into a modern supercomputer to create a model of what the initial phase of the eruption might have looked like. This approach allowed scientists to visually observe all stages of this grand natural event and assess their scale. During the modeling, experts were able to roughly reproduce the moment of eruption initiation and show several phases through which this volcano passed. Expeditionary research and analysis of the collected data helped establish the exact location of the catastrophic eruption in the strait zone between Java and Sumatra Islands. Using data from tree rings, ice core records, and eyewitness testimonies from those times describing a prolonged darkening of the sun, scientists were able to make a comprehensive assessment of the amount of material ejected. These indicators formed the basis for calculations of the explosion's scale and power, as well as for evaluating its consequences for the climate, flora, fauna, and human societies. Based on the models created and the data obtained, scientists reconstructed the picture of the massive Krakatoa eruption that occurred 5 centuries ago and envisioned what this event looked like. During the eruption, a huge fountain of molten rock arose, along with flows of lava and extensive ash clouds that cloaked the surrounding landscape in a dark, gloomy cover. Following this, another significant and extremely powerful stage took place. The formation of a secondary fracture, which allowed seawater to penetrate into the magma inside the volcano. This contact triggered an even more powerful explosion and contributed to the formation of a gigantic magma fountain approximately 30 miles high, equivalent to a destructive force capable of altering the face of the planet. The influence of such a powerful natural catastrophe, capable of striking the Earth from a distance of up to 1,000 miles, is staggering and of a global nature. After the eruption, ash like an invisible wave swept over forests and wide fields, covering them with a gray-black shroud. Tall clouds composed of dense vapors, gases, and fine ash particles began to rise upward, slowly but irreversibly climbing higher and higher into the atmosphere. At first, it seemed they had reached their apex, preventing further ascent, yet they continued their journey, carried by air currents, until they finally reached regions where they began to break apart and disperse. The atmosphere filled with grayish-white clouds that slowly, inexorably moving across the sky, resembled enormous mushrooms or domes reaching over the land. This eruption, accompanied by a powerful release of ash and gases, caused what is known as a nuclear winter, a prolonged period of cooling triggered by the blocking of sunlight by a thin layer of particles dispersed in the air. The precipitation that fell as a result of this natural explosion is comparable in effect to the consequences of a nuclear winter that could follow nuclear conflicts. The majestic and destructive eruption of Krakatoa, which was the cause of this global impact, had consequences that affected the entire world, as if struck by an unseen hand of destruction. Thanks to this influence, it transcended a local catastrophe and became a catalyst for changes in the climate and ecosystems of the planet. Scientists tried to understand the magnitude of this influence, how it might have altered the meteorological conditions, sunlight levels, and consequently, the living conditions on Earth. One of the key scientists studying such phenomena was Ken Wells. He carefully analyzed the consequences of the Krakatoa eruption and noticed that similar events had occurred in distant past. For example, millions of years ago, during an era known as the Paleogene in the state of New Mexico, in the region now called Valle Grande, the last major volcanic explosion took place, unleashing its immense power over a span of about 15 miles. This eruption was so powerful that the ash emissions reached levels beyond typical scales and spread far beyond the state, nearly reaching Louisiana. In the geological layers found in the Valle Grande area, scientists discovered remnants of volcanic ash preserved for millions of years. It was precisely these remains that researchers studied to understand how tiny, very fine ash particles formed from powerful eruptive events could influence sunlight, refract it, and create an eclipsing effect for the entire planet. Particular attention was paid to the fact that the size of these small particles is so tiny that they can move freely in the upper layers of the atmosphere, remaining there for an extended period. Even the lightest breath taken by a baby can keep these suspended particles in the air, as moving currents and turbulence constantly suspend them. And importantly, these particles never settle to the ground immediately, as long as the airflow persists in the upper atmosphere, and it continues constantly. These microscopic ash particles and sulfur dioxide formed the basis for the sky's darkening in 535 CE. Their presence creates endless gray tones in the air, and this reduction in solar heating leads to a significant drop in surface temperatures on Earth. As a result, the decreased evaporation capacity of oceans and seas means that water hardly evaporates and turns into clouds, which in turn reduces the amount of precipitation. The world becomes increasingly dry and dehydrated, with atmospheric moisture levels decreasing. Ultimately, this condition leads to dire consequences for life on the planet. Reduced rainfall promotes large-scale droughts, which began even in southern regions and eventually transitioned into hunger and decreased agricultural yields. The dry and hot period is often ended by powerful floods, phenomena that contradict expectations but are the result of complex climate processes caused by global changes. Such natural disasters could have served as a catalyst for extensive social upheavals and disruptions in civilizational development. However, beyond the direct natural processes, the long-term consequences of such events for human civilization are of significant interest to scientists and researchers. The focus is not only on the catastrophe itself, but also on its potential impact on history and societal development. Part 29 of 48. There must be some connection between a powerful natural upheaval and the global political or social dynamics. Can a single major natural event alter the course of world history and trigger a chain of consequences that ultimately affect the fate of all humanity? This question was posed by a well-known scientist named David Kidds, who spent a long time pondering how natural disasters, especially those of global significance, impact societal development. David began studying historical mysteries and events that occurred in the 1st and 2nd centuries AD, trying to identify among known facts those that might have hidden causes linked to climate or natural cataclysms. He relied on archaeological findings, ancient chronicles, and research by modern scholars. Although the causes of some incidents remained unclear, he hypothesized that they could have been driven by deeper reasons related to natural elements. In particular, he was interested in mysteries associated with the spread of terrible diseases, which devastated the dominance of one of the greatest world powers, the Roman Empire. Over centuries, the Roman Empire, under leaders like Emperor Justinian, reached the peak of prosperity and power, extending its authority over vast territories. It was a time of strong political stability, economic growth, and cultural flourishing. But in the 2nd century AD, in the year 542 AD by our calendar, an event occurred that marked the end of this bright era. What exactly happened in that long, dark year? At that time, in Constantinople, the heart of the empire, a terrible epidemic broke out, claiming thousands of lives and destroying the social fabric. A contemporary of those events, a monk known as Eugorius, left detailed descriptions of what he saw and felt, recounting the fears, panic, and chaos that gripped cities and settlements. People in despair sought salvation, but the disaster penetrated all spheres of life, destroying even hopes for the future. This disease, it seems, was so dangerous and widespread that it affected not only people, but also triggered global disruptions related to social, political, and economic spheres of the country. And here's the interesting part. Despite all the terrible uncertainty and chaos, scientists and historians continue to ponder and seek explanations for these mysterious events, because the causes and mechanisms of their occurrence remain not fully understood. At the beginning of his account, it's worth noting that some of the ill displayed dangerous and painful symptoms related to heat affliction. Their eyes bled, the skin of their faces swelled and became painful with edema, and the disease progressed very quickly. Soon, such people could not endure the suffering and died, leaving behind troubling evidence of their tragic fate. However, in other infected individuals, the symptoms manifested differently. There were intestinal hemorrhages, which also signaled an impending death. It was Eugri, a historian whose contribution to depicting the broader picture of epidemics is especially valuable, who documented in detail the extensive devastation caused by what was then called the bubonic plague. For the first time in history, an outbreak of this disease was recorded, indicating its new scale and nature. Modern research suggests that this persistent spread of the infectious agent could have been triggered by the effects of a climate catastrophe that occurred approximately 7 years before the emergence of the disease. According to historical data, this catastrophe significantly affected living conditions and the environment. The disease itself is a bacterial infection caused by a specific type of bacteria known as the plague bacillus. Its transmission mechanism is quite complex and closely linked to vectors and intermediary links in the infection chain. The primary carriers are not only humans, but predominantly rats, which are concentrated sources of infection. The transmission occurs precisely through invisible and highly bureaucratic fleas that feed on these rodents' blood. During feeding, a flea becomes engorged with blood. However, when it becomes a carrier of the plague bacteria, changes occur inside its intestines. Comparing healthy fleas that feed on innocent and clean rats with fleas infected by bacteria, one can notice that the former appear quite normal, showing no signs of illness and seeming perfectly healthy because their intestines contain no microorganisms, bacilli. In contrast, Fleas that have fed on an already infected and sick rat experience a horrifying process: obstructed intestines. This is caused by the interaction between the bacteria and the flea. The bacteria break down the digestive tract of this bloodsucker, destroying it. As a result, the flea, deprived of the ability to digest food normally, experiences extreme hunger. It becomes contaminated, and this hunger begins to accumulate. Since it cannot satisfy this burning desire, the flea tries to jump onto any mobile object in hopes of finding a new host. As soon as the flea bites a human or another warm-blooded creature, it transmits the bacteria. Today's scientists know very well that this is exactly how it happens. And then a chain of terrifying events begins. The infected person becomes part of a vast and destructive process. Rats suffering from the infection become increasingly weak links in this chain. They die, and their bodies are attacked by carnivorous fleas, which in turn seek new blood sources. These blood-sucking insects move through the city, aiming to find a human and bite him in order to access his blood, rich in nutrients. People bitten by fleas start to suffer. They exhibit a variety of symptoms. One of the first manifestations of the uvegrey infection is described as a severe fever that literally overcomes the patients. Some of them experience a bright and blinding rage when they go out into the streets armed with swords, seemingly hoping to fight an invisible enemy. This state persists for 2 or 3 days, after which the condition of the infected rapidly deteriorates. Many die while still appearing outwardly strong and healthy. Their bodies seem untouched, as if death has bypassed them. On the other hand, there are more tragic cases when the dying lose their reason just moments before their last breath, becoming disoriented, turning into semi-mad beings who rapidly lose control over themselves. To understand the causes of this tragedy, scientists conducted studies and reached important conclusions. Outbreaks of the plague are closely linked to climate changes. In particular, their research emphasizes the crucial role of air temperature fluctuations. A constant decrease or rise in temperature directly affects the development of the bacteria in the flea's intestines, ultimately determining the disease's ability to spread. The most critical threshold is a temperature below 25 degrees Celsius. Under such conditions, dense fibrin clots form in the flea's intestines, serving as the site for the accumulation of the plague bacteria. If the temperature exceeds this threshold, the bacteria are simply expelled with the flea's feces before forming an intravascular clot, allowing the infection to spread much more rapidly. This raises the question: was the widespread cooling that facilitated the spread of the plague actually caused by the cooling event in the year 1335 AD? And if so, where exactly did this large outbreak originate? Modern historical sources, such as one attributed to the church historian Evagri, indicate that the origins of the pandemic can be traced to Ethiopia. It is known that the region of the Great Lakes in Central Africa is one of the oldest plague hotspots in the world, supported by both scientific and historical evidence. Evagri's assertion appears quite convincing, as the hot climate of this area could slow the development and spread of the bacteria, thereby suppressing a pandemic. However, during the sharp cooling that affected Africa in the year 1335 and 1336, this region could have become an especially vulnerable source of infections. Over time, climatic changes might have altered the pattern of disease spread. In this scenario, maritime routes would have been a likely channel for the infection's infiltration into other regions. Rats and sailors had long been familiar with each other, and it was precisely through ports, starting with the port of Alexandria, a major trading hub, that the infection could have entered coastal cities. Consequently, the infection spread swiftly through the commercial network, capturing new regions and states, including the heart of the Roman Empire. The greed of ancient Rome towards African elephants played its destructive role in accelerating catastrophic events that later engulfed an entire civilization. During that period, ivory trade became one of the most important sources of income and luxury, as this valuable woody material, extracted from elephants, was transported annually in vast quantities, hundreds of tons, from the African continent to the empire. There, it was widely used in manufacturing interior items, furniture, and decorative elements that symbolized wealth and sophistication. Noble and influential magistrates, rulers, and the aristocracy exchanged these precious gifts, often as surprises, tokens of status, or in medieval diplomatic games, to win favor or strengthen alliances. Furthermore, such gifts were used during official visits and negotiations to impress and demonstrate the empire's strength to neighboring states to the north and west. Not least, at that time, many people who had never seen real elephants before encountered this extraordinary phenomenon, because the elephant, an enormous, wise, and majestic creature, became part of their daily lives only in these ceremonial contexts. Ultimately, it can be said that this civilization, at its dawn, rooted in European and Mediterranean peoples, penetrated the culture of their neighbors and the lives of their aristocrats through these goods, symbols of wealth, status, and diplomatic ties. However, such greed and avarice led to unforeseen and destructive consequences. In 542 AD, a climatic catastrophe devastated Constantinople, then the largest city of Europe, triggering a widespread outbreak of the plague, which was caused by uncontrolled ivory trading. A seemingly small greed, a lack of restraint in trade, turned into a global tragedy. The disease, spreading throughout the city, was so destructive and deadly that over 10,000 bodies had to be disposed of daily. People faced the necessity of employing various methods to cope with the growing number of the dead. Some bodies were thrown into the sea with small boats to minimize the risk of spreading the infection. Others were buried in special graves within the city walls. Some were hidden in sewer systems or even used to landscape gardens, strengthening and transforming the land. The military had to establish mass graves to bury the numerous victims of the disease. Months passed, and from the city, once one of the greatest centers of European civilization, issued a stinking wave filled with a terrible smell, growing stronger and stronger. One modern writer, reflecting on the tragedy, noted that when the number of deaths reached 250,000 people, the city authorities simply stopped counting and keeping track of the fallen. Winding flows of refugees swept the entire city out of the infected zone, and the plague began to spread rapidly across all regions of the empire, through small villages, farms, and other towns. Millions of people, victims of this relentless disaster, perished without leaving anyone alive. In the east, a different empire was gradually forming, unnoticed and unaffected by these events. But this new civilization also played its negative role in the decline of Great Rome. The impact of the climatic catastrophe also affected the peoples living far to the east and contributed, sometimes negatively, to the disintegration of the Roman Empire, as it was precisely there that new, dangerous challenges arose for the entire world. The cause of this new and perilous challenge of our times was the difference in digestive systems and metabolic processes between horses and cattle, which had far-reaching consequences. Within Mongolia, on vast and nearly isolated plains, stretches extending hundreds of miles north of China, strange and unusual events took place that later proved significant for world history. Before the beginning of the 6th century CE, the region was ruled by greedy and brutal conquerors, the Avars, whose armies carried out relentless raids day after day and held this territory firmly in their grip. Chinese historians describe them as barbarians, dressed in tattered, dirty clothing. The smell emanating from them was unpleasant, and their strange, unfamiliar customs didn't help the situation. The Avars never cared for hygiene. They did not wash their clothes, and did not wash dishes, while women were forced to lick dishes clean after meals, which caused great disgust and horror among the Chinese. However, despite their unfamiliar poverty to the Chinese, the Avars had an advantage. They were years ahead of their rivals in defensive and strategic technologies. Archaeological excavations and studies from that period, conducted in territories inhabited by the Avars, confirmed that in terms of horsemanship, methods of horse management, and the design of saddles and bridles, Avar science and craftsmanship exceeded others. It is believed that they were the first to invent and implement stirrups, which significantly enhanced their military capabilities. Thanks to the large number of horses they bred and used, the Avars gained a strategic advantage that became the ultimate word and military technology of that time. Horses served not only in battles, they were also a vital source of food, as meat and milk from these animals were essential for survival. Fermented mare's milk, used to produce alcoholic beverages, was considered one of the key components of their diet, making horses an inseparable part of their survival and prosperity. However, in the years 535 and 536, events occurred that changed the fate of the entire region and the entire course of human history. Records made in China and data obtained from the annual rings of trees found in Siberia indicate that ancient times, the vast Mongolian steppes experienced a period characterized by severe climate fluctuations. These changes were associated with long-term cooling and scattered air dryness, which led to a complete halt or significant slowdown in the development of vegetation and life in this extensive area. The consequences of such climatic conditions had a profound impact on the whole region, creating a domino effect that gradually spread over the decades, altering not only the natural environment, but also the fates of the peoples inhabiting these lands. One of the significant chronological markers of this period is the year 1552 AD. On that day, a landmark event took place. The peoples previously under the control of the Avars, the Slavic people mentioned in historical sources, were subjected to an attack by shamanistic, nomadic Turkic tribes living in neighboring mountain regions. It was the Turks, at that time not yet dominant in this area, who decided to exploit the weakness of the Avars to destroy their limited forces and expand their territories. As a result of this attack, the once mighty Avar horsemen, renowned for their combat effectiveness and invincibility, suffered an unfortunate defeat. This unexpected outcome led to a sharp change in power and dominance in the region, which remains a mystery for historians and archaeologists to this day. There are many explanations for the causes of such a turn of events, but the final version continues to be unknown. Nevertheless, researchers have developed an intriguing hypothesis that could fundamentally change the perception of the causes of the recent changes. One of the ideas that attracted particular attention from young scholars was the question of possible dependence between economic factors and political events. Reports indicated that the Avar economy at that time was mainly focused on breeding and utilizing horses as the primary means of transportation and weaponry. Meanwhile, the economy of the Turkic tribes was much more diversified. Besides horses, these nomads widely bred cattle, which allowed them to maintain a more stable and diverse economy. In this context, scientists were interested in the question: could the difference in economic structures, the presence or dominance of a certain type of livestock, have somehow influenced the political landscape and ultimately contributed to the defeat of the Avars? In search of answers, a Chinese researcher named David Kez approached a colleague, John Milne, a land use specialist in Aberdeen. This scientist conducted a comprehensive study to understand how differing diets and habits of animals could influence their survival in the harsh steppe environment. During his work, Milne arrived at some interesting conclusions. He noticed that the horses used by the Avar nomads were actually closest to mountain ponies, although they looked and were similar in size to the region's typical Avar horses. By analyzing the structure of their manure, the scientist observed that it was more fibrous and contained large pieces of fiber, indicating incomplete digestion of food. In contrast, the manure of cattle was finer and their bodies absorbed nutrients more efficiently. These differences proved especially important on the Mongolian plains, where environmental conditions were often unfavorable. The quality of vegetation was severely affected by prolonged droughts and adverse climate changes. The variety of plant feed available to cattle allowed them to process food more effectively and adapt to poorer or infected pastures. Unlike horses, which in the struggle for limited resources could experience significant difficulties in obtaining and digesting enough food, cattle were more resilient in harsh conditions. They tolerated plants that were unsuitable for horses, which flourished during dry periods, and made efficient use of available food resources. As a result, during severe droughts, when good grass became scarce, horses often found themselves in a difficult position because with insufficient food intake, their bodies could not fully absorb energy, which was catastrophic for their survival. In such circumstances, the Avar nomads themselves became highly vulnerable. Their mobile society depended on stable resources to feed their horses, and a shortage could lead to mass losses and even the complete collapse of their economy. It was precisely in this context that scientists identified a very important aspect that revealed one of the reasons behind the unusual geopolitical turning point in the history of the region. I was personally struck by the fact that differences in the structure and functioning of the stomachs of cattle and horses could have such a profound influence on the course of historical events. According to Chinese chronicles, after the defeat by the once-conquered Iranian Turks, thousands of our compatriots who remained alive either died or were taken into slavery. Their leader, undoubtedly despairing entirely, committed suicide to avoid falling into enemy hands. Most of the remaining Avars decided to undertake a long and arduous journey westward, hoping to find new lands and start anew. This was a very difficult and risky expedition, covering approximately 4,000 miles. Modern researcher David Kiss asserts that this catastrophic situation and the associated forced flight became a catalyst, triggering the collapse of old orders and the creation of new historical conditions. The journey of the refugee tribes passed through territories now known as northern Kazakhstan, a vast and fertile steppe region characterized by endless expanses, and then circled around the northern coasts of the Caspian Sea, traversing plains washed by its waters. Later, this caravan moved into an area that is part of modern-day the Balkans, south of the Carpathian Mountains, where fertile meadows with lush grasses could be found. It was in these lands, far from their native steppes, that they hoped to find a new life, rest, and heal the wounds inflicted by war, hunger, and brutal natural disasters. Thus, the remarkable and tragic pages of our ancestors' history vividly illustrate how complex the chain of causes and effects could be, connecting climate changes, economic factors, and political conflicts in a distant era. Over many centuries, the Avars gradually revived and refined their horsemanship skills and cavalry tactics, which still surpassed all the weapons and equipment they encountered on their long and arduous journey. These people once again achieved the status of conquerors, subjugating numerous tribes occupying vast territories, and became one of the strongest peoples of Eastern Europe. Soon after, Roman historians and chroniclers began to mention how representatives of this nation reached the borders of the most powerful empire at that time, the Roman Empire. The period of their appearance on the historical scene is generally dated to the mid-6th century, specifically to the late 450s AD, when the Avars arrived in Europe mainly as refugees fleeing internal conflicts and disasters. Within a decade of their arrival, they managed to establish control over and unite under their rule a number of Slavic tribes, Huns, and Germanic peoples who had historically inhabited lands north of the Danube, along the empire's borders. After subjugating these peoples, their attention shifted to the grandest state, the Roman Empire itself. At that time, the empire was experiencing troubling processes of decline, suffering from devastating plague outbreaks, social upheavals, and internal conflicts. Continuous raids and attacks by the Avars caused concern among the rulers of Constantinople. During one of these critical moments, the Avars found themselves under siege by barbarian forces. However, instead of seeking to seize power and fully control the capital, they chose a different strategy: blackmail and political maneuvering. As early as the first decades of their dominance, they began receiving substantial sums from the empire, quite literally in large quantities of gold, in exchange for promising peace and avoiding bloody battles. These payments later became part of their incentives for maintaining power and control. Today, these historical events can be viewed through the lens of museum artifacts, part of the spoils collected by the Avars over years of raids and invasions. Today, these items are displayed as relics, while a significant portion, according to scholars' estimates, remains buried somewhere beneath the earth, hidden under layers of time. On the plains of modern Hungary, it is estimated that over a quarter of a century, these nomadic Avars managed to accumulate in gold, or its equivalent amounts, totaling what is now valued at £7 billion. The influence of the Avar people, compounded by devastating outbreaks of the plague and subsequent economic crises, led to the gradual instability and chaos of their empire. All these events are linked to global climate changes caused by catastrophic natural phenomena, particularly the eruption of a giant volcano in the mid-10th century. Historian David Keyes discovered that this very disaster had far-reaching consequences for the politics and history not only of Europe and the East, but surprisingly, for the American continent as well. His research reveals important patterns showing how natural disasters influence the course of historical processes. He found compelling evidence that, as a consequence of the eruption, large-scale political transformations occurred over more than a century in Europe and Eastern Europe. Currently, his interests extend to one of America's mysterious cultures, where he identified a remarkable chronological coincidence and an intriguing historical riddle. In the early 6th century AD, in the central plains of Mexico, at a site now known as Teotihuacan, approximately 125,000 inhabitants lived, a population considered very large for that time and region. By the year 10 AD, when the city reached its zenith and became a major cultural center, it can be regarded as one of the largest urban settlements in the world, ranking only slightly below some of the major cities of that era in terms of population. Honestly, the scale of those times was so vast that it was hard to imagine that such large settlements existed elsewhere, although individual cities numbered around 10 or 20,000 residents. At that time, the central Mexican plateau was virtually the only major densely populated zone, and Teotihuacan distinguished itself by its size and significance. However, everything changed after the catastrophic events that occurred in the mid-6th century, especially following the numerous calamities that began in AD 535 and marked that period. About 20 years prior, a volcano had erupted, triggering powerful eruptions and natural disasters, which had a devastating impact on the entire regional culture and its population. As a result, the memorial evidence, human remains found in the suburban area of the city known as Tlahinga, allows us today to trace the evolution of the health status of its inhabitants over subsequent years. Archaeological excavations uncovered numerous skeletons of adults as well as children and infants, indicating a diverse and thriving population. Notably, recent decades have seen scientists conduct detailed studies of remains dating from after the 6th century and draw significant conclusions about the deterioration of public health, especially among infants and young children, which points to harsh living conditions and a weak healthcare system at the time. Among the findings are signs of prolonged bacterial infections. Today, such diseases in children are considered common, but back then, they more likely served as evidence of large-scale epidemics and severe living conditions faced by inhabitants of this ancient city. Although infants generally have a good chance of survival, thanks to a strong immune system inherited from their parents, particularly from their mothers, we are nonetheless faced with astonishing and alarming facts indicating the opposite. In cases related to the disease known as Klahinga, numerous examples have been found of newborns and very young children already showing signs of various infectious reactions, something that would not occur if they had a robust immune defense typical of healthy infants. This situation points to extremely poor maternal health. Their bodies were suffering, and consequently, their children suffered as well. This problem becomes especially evident considering that, in the society occupying the territory now known as Mexico, around the end of the 6th century, most of the population consisted of newborns, children, and individuals no older than 25. Such widespread mortality, especially among such a young and still maturing population, should not have occurred. In my research sample, approximately 70% of participants, those in the most vulnerable and youngest age group, were present, whereas in earlier eras, this figure ranged between 40 and 50%. These data clearly indicate the dire condition of the community at that time and suggest that the population was under threat of complete annihilation, either as a result of a catastrophic crisis or due to other devastating factors. Recent scientific studies offer new insights into the city's decline, suggesting that its destruction began around the mid or late 6th century. For researcher David Keyes, this perspective was a true breakthrough, an entirely new understanding of the situation. Thanks to this discovery, it becomes possible to understand that the fall of Teotihuacan was not accidental or sudden, but closely linked to a global climate catastrophe that affected regions of Mexico and surrounding territories. It is important to note that today, there are no archaeological findings within Mexico itself, such as tree ring data or other evidence, confirming severe climate changes. However, studies of lake sediments on the nearby Yucatan Peninsula show that around the mid-6th century, a 30-year drought began, significantly undermining the region's natural resources. Similar findings have been made in other areas. Annual tree ring data collected from Chile and California indicate a sharp decline in tree growth in the late 1950s and early 1960s. Additionally, analysis of river levels in Colombia suggests that the mid and late 6th century were the most arid periods of the past 3,000 years. These diverse and extensive pieces of evidence, gathered across different continents and climate zones, when compared with the conclusions of expert Rebecca regarding widespread malnutrition among the population, allow a confident conclusion. Tenochtitlan, one of the greatest cultures of ancient Mexico, endured a prolonged and severe drought period. According to the hypothesis put forward by David Keyes, the drought was not a random natural event, but the result of a climate catastrophe that delivered such a blow to the city's food supply that its inhabitants were pushed to the brink of survival. Escalating food shortages caused the human body under these conditions to become especially vulnerable to various diseases, since their nutrition was insufficient and what was available could not provide adequate protection. In the context of a severe water shortage, particularly critical at that time, as its absence immediately caused serious sanitation problems, the situation worsened. Lack of liquid triggers almost instant disruptions in the body's purification systems, activating the spread of infectious diseases. This creates a vicious cycle. Illness, weakened immune systems, further reductions in the population's productivity, and subsequently worsening living conditions and feelings of helplessness. During such periods, people increasingly and more loudly express their dissatisfaction and disillusionment. We no longer want to stay in Tenochtitlan because this place has become uninhabitable for us. As the population's health deteriorates and the number of sick rises steadily, the efficiency of the entire city, the social and economic apparatus, weakens. As a result, the inhabitants began to express increasingly desperate thoughts about leaving their homeland, as living conditions had become so severe that they were no longer acceptable. Today, it is established that the ultimate fate of the city can be considered linked to a calamity, an uprising of the population against the local rulers. During this uprising, the residents destroyed palaces owned by the elite and set fire to the largest cultural and religious buildings. Someone gained access inside and deliberately ignited all the wooden beams of the roofs of these structures. As a result, many roofs collapsed and the massive ceiling structures fell, breaking the interior walls. In particular, the collapse occurred right on the main street of the city, demonstrating the scale of the disaster. It is possible that this violence was triggered by the population being physically exhausted by the demands imposed on them by the elite and feeling that these demands had become unmanageable. People, in their protest, decided that their suffering and fatigue had reached such a level that they collectively chose to radically change the situation, bringing destruction and chaos to the streets to show their strength and discontent. In those distant times, when society was still trying to understand and interpret the surrounding world, many believed that the role of priests, endowed with the special gift to invoke rain and ensure a constant supply of water, gradually ceased to be as significant and effective. Likely, people began to doubt their abilities because the flow of natural sources noticeably diminished, and rain fell much less frequently than before. This decline in the priest's intervention could have led to growing distrust in the clergy as a whole among the people. Underlying processes of destabilization, whether hidden or overt, began to take root within society, perhaps intensified by significant changes in religious and political spheres. What started as internal upheavals could have escalated into a genuine revolution, ultimately leading to the fall of entire cities, societal fabrics, and even the shared worldviews that had been built over centuries. Such upheavals were not unique to our history. Notable instances of city falls in Europe, including the capital Constantinople, the seat of the Roman Empire, serve as clear evidence of this. One particularly striking moment in the historical record was a major event that occurred in the year 1335 AD, which dramatically changed the world scene and marked the beginning of new civilizations. These upheavals became a kind of bridge between a long-gone era and what we now perceive as modernity. 3 centuries later, in the 6th century, new states and civilizations began to form in the central part of the Mexican highlands. Despite taking about 300 years to develop, these civilizations firmly established themselves within this period. Nevertheless, during this same period in the 6th century, similar global processes were occurring almost across the entire planet. Some ancient societies and civilizations disappeared forever, making way for new ones that were just beginning their existence, while others continued their path, strengthening and developing. Let us turn to the opinion of the well-known historian David Kish, who notes that one of the most vivid and characteristic examples of the birth of a nation and state in the era after the fall of Rome is England itself. In the mid-6th century, exactly 100 years after the Roman legions left these lands, the local Celtic tribes in the west of the island continued to resist the powerful advances of the Anglo-Saxons, newcomers from northern Europe moving south and east. In this turbulent period, according to legends and traditions, the great King Arthur was no longer among the living, and the country, which once was renowned for its power and wealth, found itself plunged into chaos and decay. Far beyond the horizon, lands covered in dust, partially devastated and scarred. This is how an artist might have depicted that moment. King Arthur had fallen, and his country was in a state of deep decline. He traversed lands strewn with ruins, surrounded by fallen trees, damaged crops scattered across the terrain. It felt as if a lightning strike had swept through these plains. So sudden and destructive was this calamity. Many villages were ravaged, and half of the population perished, unable to survive the destruction. The land that was once rich and fertile had lost its ability to yield abundant harvests, and wheat and other cereals no longer grew there. Trees stopped bearing fruit, and fish virtually disappeared from the sea. As a result, these territories turned into a monstrous wasteland, devoid of life and greenery, and two kingdoms came to be called precisely that: the Wasteland. Some researchers suggest that this legend of the abandoned land might have real historical roots. Perhaps it refers to a prolonged climatic catastrophe that truly shook the British Isles at that time. Likely, the tragic events during the period of Patustri, a tyrannical and harsh era, left their mark on both the region's climate and its culture. Scientists examining finds related to the ancient fauna and flora of the British Isles and Ireland conclude that one of the factors of this catastrophe was the bubonic plague, which, they hypothesize, entered these lands at the end of the 5th or beginning of the 6th century AD. According to archaeological evidence, the first sign was contact with ports along the coast of Cornwall, a strategic trading hub. It was through these harbors, which largely maintained connections with the remnants of the Roman Empire, that the infection spread into the interior of the islands. This terrible disease, which later became known as the Great Mortality, marked a turning point in the history of the English-speaking countries of the West. It should be especially emphasized that at that time, thanks to maintained trade connections, the disease spread not instantly but gradually, primarily affecting ports and coastal regions. The first recorded mentions of the bubonic plague refer to it by various names, including Martellatas Magna or the Great Mortality, indicating the scale and severity of this terrifying epidemic. Other sources describe it as Martellatus Prima, or the First Plague, highlighting its unique and unprecedented nature, as such large-scale diseases had not previously appeared in this region. This was a true trial for the people because they faced such a terrible illness for the first time and knew nothing about its nature or how to combat it. The disease manifested as boils appearing gradually under the armpits and around the groin, and the afflicted person died a painful death, overwhelmed by terrible suffering. The epidemic radically changed the political situation in Britain, which at that time was divided into two parts. These lands and regions were experiencing an extraordinary period of development because droughts, epidemics, and famine all contributed to the breakdown of established order and the emergence of new structures, either more resilient or conversely, more vulnerable. In the Western Territories lived the descendants of ancient Celts, a people who had preserved their cultural and historical identity since deep antiquity. Meanwhile, in the east of the region, new invaders from Europe, the Angles and Saxons, broke into foreign lands and began to establish their dominance, creating new ethnic groups and societies. These two peoples, the Celts and the Britons, had almost no contact with each other. Their paths rarely crossed, as each remained within their own territories, and there was no rush to interact. At the same time, the Anglo-Saxons began conducting active trade with the homeland of their ancestors, the lands in Germany and Scandinavian countries, which played an important role in their development and the strengthening of their power. This commercial exchange, built on trade links, contributed to the gradual expansion of the Anglo-Saxons' borders, and their influence on lands inhabited by Celts and Britons became increasingly apparent. As a result, the vulnerability of the Celtic peoples to new diseases, especially such destructive ones as the plague, greatly increased because their defense systems proved less prepared for threats coming from outside. This pandemic which arrived in Europe from a symbol of the power and decay of the Roman Empire, claimed millions of lives, and ultimately, by the middle of the century, roughly the middle of the 5th millennium AD, the population of Celtic lands in the west and center of Europe diminished to such an extent that a void was created, comparable in scale to destructive wars or natural calamities. As a result, the demographic vacuum became a springboard for migration and resettlement of new peoples, primarily Anglo-Saxons, who took advantage of this situation and managed to cross borders that had previously belonged to the older inhabitants of these territories, settling on lands once dominated by the Celts. According to the existing hypothesis, known as the key theory, the emergence of England is attributed precisely to the fact that the Anglo-Saxons defeated the Britons, who had been significantly weakened and exhausted by a terrible plague. A chronicle dating from roughly the 6th century describes the defeat of one Celtic group led by a man named Gadatine. This warrior, known for his bravery and resilience, participated in bloody battles alongside his commander Medoc, where bloodshed was like a river and the fighting was fiercely brutal. Those who fought refused to surrender or flee, regardless of the circumstances. After the war, Medoc found that only about 100 of his men remained around his camp, a testament to the scale of the losses and the tragedy the Celts had endured. This event, which occurred around the 15th century AD, can be considered a turning point when forces began to emerge on the global stage that would give rise to major nations such as England, Spain, France, Japan, and United China. Historians today reflect uniquely on this chapter of history in the 21st century. However, there is also a bolder hypothesis. Some believe that the destiny of these peoples is fundamentally linked not only to the formation of new states, but also to the birth of a new world religion, Islam. This unusual assumption is based on the idea that historical catastrophes, epochal changes, and migrations of peoples could have contributed to the awakening of new spiritual movements, particularly the Islamic faith. Today, only ruins remain of the famous ancient dam in Yemen, the city of Marib, serving as a reminder of the bygone era of a great structure. In the beginning of the 6th century AD, Yemen surpassed most neighboring states, and its wealth, developed economy, and infrastructure were largely built around this grand engineering feat. The Marib Dam was a true engineering marvel, about 2,000 feet long, and it controlled a system of channels supplying water to hundreds of miles of surrounding land. Shortly after the disaster that occurred in 1535, the country faced climatic upheavals, marked by a drought accompanied by a series of storms and heavy floods, which destroyed or severely damaged the remaining dam. Continuous efforts to restore this unique structure are reflected in the preserved inscriptions. On the facade of the ruined dam, records were made expressing gratitude to all those involved in its repair and rebuilding. Among these Soviet-era inscriptions, one dating from the year 54 stands out. It described the reconstruction efforts and the work undertaken to restore the structure. At the center of this inscription was a cartouche portraying the ruler's authority, one of the influential figures of that era, symbolizing his power and support. These commemorative inscriptions remained on the walls and stone slabs for approximately 2 or 3 centuries, serving as a constant reminder of the great labor and effort involved. However, over time, according to Arab sources, during a certain historical period, this dam, Marib, was breached and destroyed, and it was never rebuilt. After this disaster, the situation in the region changed dramatically. The drained reservoir became the cause of a humanitarian and ecological catastrophe, and the people began to migrate en masse to new, safer territories near the cities that had gained new significance. New centers of power emerged in the region's political life, especially around the sacred cities of Mecca and Medina. It was in Mecca, around the 70th year of our era, that the future prophet Muhammad appeared, destined to establish a new religion. It was in Medina, part of the Meccan region, that he found refuge after fleeing his homeland, the Hijra. Thanks to this event, Medina became a center of political and religious development, exerting a crucial influence on the early formation of Islam. Recent climate changes have had a profound and multifaceted impact, not only on the natural environment, damaging the dams and prompting the transfer of power centers to Medina, but also significantly increased the popularity of Muhammad's family among the population. Understanding the growing need to ensure food supply for their fellow countrymen, the ancestors of the Prophet took on an important task: to organize food deliveries to this region, importing supplies from distant areas. This step was part of their strategic initiative to strengthen social recognition and elevate their status among the people, which at the time was a key factor in consolidating authority. The reputation of Muhammad's family, associated with caring for societal welfare, played a vital role in reinforcing his activities, especially during difficult periods marked by droughts, famines, and plagues that spread from parts of the Roman Empire. During these challenging times, when natural disasters and diseases affected entire regions, the words and deeds of the Prophet gained particular appeal and significance. Their message was able to inspire hope, to fill hearts with faith in a better future, and it was during such eras that it became especially relevant. It is believed that during this difficult historical period, Muhammad's ideas found their particular strength and resonance among the masses as people endured times of intense conflicts and profound upheavals. In the ancient world, an atmosphere of apocalypse prevailed. Wars, revolutions, and unrest blended into a chaotic and uncertain picture. At the same time, the Roman Empire, long considered a giant of world politics, began to sway under the pressure of internal and external problems, losing its former positions and influence. During this period, numerous texts, prophecies, and visions emerged about the imminent end of the world, impending disasters, and the closing of civilization's era. People perceived these events as signs that the world was heading towards its final stage. Public mood was filled with fears and anxiety. Political stability deteriorated before their eyes. Confidence in the future vanished, giving way to suspicion and apprehension. The era was imbued with a sense that a storm was coming, capable of destroying everything that existed and erasing all human achievements from the face of the earth. Meanwhile, atmospheric phenomena, caused by a powerful volcanic eruption in the year 535, added to the atmosphere of chaos. This event had catastrophic consequences, triggering global disasters that affected natural processes and civilizations of the time. As a result of these upheavals, the old world was significantly devastated, and on its ruins, a foundation was laid for new formations, including the future of Islam. Considering the impact of this eruption, which was powerful and far-reaching, it becomes clear that even a minor tremor or a new, powerful volcanic eruption in the future could cause even more drastic changes. Such hypotheses should not be regarded as mere fantasies or speculation. Over the next 100 years, significant catastrophes are unlikely, but deep within the Earth's crust, numerous enormous volcanic systems lie in wait, long feared by scientists. These systems are waiting for their moment and could awaken suddenly, bringing new calamities. One of the most well-known and significant is the Yellowstone caldera in Wyoming, which is considered the ancestral mother of all modern shopping centers around the world. This caldera exceeds the size of any other known caldera on the planet and is twice as large as most contemporary formations. Over the past 2 million years, it has repeatedly awakened and erupted lava, leading to the destruction of large territories of North America, as if erasing them from the face of the Earth. Besides Yellowstone, there is another giant caldera in California, which also influences the Earth's crust, causing earthquakes and increased geothermal activity. Signs of dangerous activity have long been observed in this region. The soil and land are heating intensely, and harmful gases like carbon dioxide are escaping to the surface, leading to the death of forests. It is evident from the environment that the forests in this area have already fully died out, as life there has practically vanished due to the toxic gases saturating the air and ground. It is quite clear that such volcanic activity causes serious concern among scientists and experts who are worried about possible consequences. Many people today feel a particular tension and anxiety, especially those living near these dangerous zones. The most accessible and noticeable place where one can sense volcanic activity is the area around Naples in Italy. This region is known for its rich history and unique natural beauty, but also for its potential threat. It is home to the famous Mount Vesuvius, which has erupted multiple times many centuries ago, destroying everything around and leaving behind traces of the immense power of nature. There is a possibility that Vesuvius could awaken again in the future, and its eruption might lead to a large-scale disaster. Besides Vesuvius, there is another potentially dangerous volcano located north of Naples, in the area known as the Flegra Fields and Puscoli. About 400,000 people reside there. This settlement's risk increases significantly in case of active volcanic activity. The first major signs of activity in this volcanic complex were recorded in the years 1338, when a sudden eruption claimed the lives of 3,000 people and caused tremendous destruction. Today, this complex is regarded as a potential source of powerful eruptions that could trigger catastrophic consequences, not only for Italy, but for the entire European continent. Moreover, the global climate consequences of such events are not limited to European regions. Volcanic vibrations and the emissions of ash, smoke, and gases can significantly alter atmospheric processes, contributing to global droughts or cooling. These dangers highlight that in the depths of the Earth's crust lie forces capable of changing the course of human history. In this context, it is important to remember that despite temporary calm, these giant volcanoes can wake up at any moment, serving as a reminder of humanity's inescapable connection with the Earth's immense power and its unwavering capacity for change. The consequences of such events can have such a profound impact on agriculture that their scale is difficult to overestimate. Potential changes in the climate could lead to large-scale disruptions in normal precipitation patterns and periods of prolonged drought covering vast territories. These phenomena often manifest in minor ways, such as El Niño or La Niña cycles, which have long caused concern and debate among scientists and specialists. However, the nature of powerful volcanic eruptions is a completely different event in scale and force. Their impacts can be many times more significant and destructive for the entire planet. As a result, the average global temperature can decrease by several degrees in a short period, and sometimes even more. This, in turn, will create a situation in which human activity and natural systems will be under severe pressure, causing colossal changes in the climate. One of the most critical and unpleasant outcomes of this will be disruption in food supply for the population, a widespread and vital sector. The time required to restore normal climate conditions or for farmers to adapt to new circumstances could stretch over decades. During this prolonged period, many traditional agricultural methods will become either obsolete or significantly more complex. The import of food from other countries will become virtually impossible, as similar ecological problems will also occur there. Resource shortages, unpredictable climate fluctuations, and breakdowns in transportation chains. Ultimately, if agriculture cannot produce enough food, the issue of food shortages will become critical for all humanity. Looking into the past, it is evident that, in earlier times when population density was much lower, people successfully relied on relatively unpretentious natural resources, such as marine reserves. Back then, harvesting shellfish from the coast was easier because conditions conducive to this activity were more prevalent. During periods of great upheaval, it was precisely such survival strategies that allowed people to endure. However, today the situation has changed dramatically, and seafood harvesting has become much less accessible, more complicated, and more costly due to ecosystem changes that have already reduced their abundance. If a global catastrophe occurs in the future, it is quite difficult to imagine how we will cope with its consequences. The collapse of civilization's infrastructure under the blows of ecological disasters, such as mass crop failures, darkened skies, and loss of communication, could lead to instant chaos. The shutdown of transportation systems, including air and rail transport, would disrupt supply chains and create a long-term logistics crisis. All these factors combined could trigger a chain reaction, where people begin fighting for limited resources, inevitably leading to conflicts and wars for survival. In today's world, saturated with information and interconnected through a global system, such scenarios evoke particular worry and uncertainty. In conditions of acute food shortages, when no other options remain, individuals will be forced to fight for every morsel, for every available source of nutrition. Under extreme stress and frightening pressure, going without food becomes impossible, and the choice reduces to either seeking initial resources or facing a tragic fate. From the events of the year 535, considered one of the most mysterious and significant in history, I have learned an important lesson. It is not about swift and rapid changes, but about a destructive explosion that leads to a long cycle of transformations. Recovery from such a shock can sometimes take between 100 and 150 years, during which a new reality is shaped. Of course, predicting the future is difficult, and no one can give precise answers about what exactly awaits us. However, I believe that historians, economists, and policymakers should pay much greater attention to studying the impact of natural disasters on the course of history, as they have often served as catalysts for major global changes and crises that we discuss. A more careful analysis can reveal how natural forces contribute to the development of civilizations, their rises and falls, and how important preparation and societal resilience are to withstand potential upheavals in order to reduce their destructive effects.